From the last two example, I hope it is almost clear how to create a merger graph from a incompletely specified machine, which is basically a machine that is created from the NFA, and from that merger graph how to reduce the machine using merger table, and also how to create the set, how to find out the set of pair of states which is satisfying the properties minimal closed covering. Now this time we will show you how to create how to do the same problem using merger table. Both of merger table and merger graph both are equivalent. Only thing is that sometimes you will be asked to solve the problems using merger table, or sometimes you may be asked to solve the problem using merger graph. But if the number of states are more, as well as if you find out that most of the states are specified, only few states are incompletely specified, that case the merger graph will be little bit clumsy. So better to go for merger table rather than merger graph. This is a suggestion, this is not the thumb rule. Here also we can find it out, you can find it out that only two states C and F is incompletely specified. Most of the states are specified. So if I draw the merger graph instead of this one, then it will be little bit complex. Now how to draw the merger table? To draw the merger table, what you have to do, that you have to find out, figure it out that how many states are there. 6 states are there, and that case I have to draw a table with the 5 rows and 5 columns, one state less, 5 rows and 5 columns in this manner. Now the number of rows will start from the excluding the first state, that means it will start from B, C, D, E, F, and the number of columns that will start using the first state, but it will exclude the last state, A, B, C, D and E. So if we have to find out that whether A and B is compatible or not. If A and B is compatible, then we will give tick. If there is no implied pair is present, if the implied pair is present, then we will give the implied pair name also within A and B. Now why we have not included A in the first row? Because if I include A in the first row, that case I have to find out the AA pairs compatibility, but AA pairs compatibility is not possible. Similarly, we left out that F also to be as the FF pair of states compatibility is not possible. Now let us try to find out that whether A and B is compatible or not. A and B is compatible, as well as their implied pairs are AB and EF. So we will not check the implied pair for the AB because we are going to find out the compatibility of AB only. Now let us check that whether EF is compatible or not. EF is also compatible. Now we can write that A and B is compatible and its implied pairs are E and F. Now check for whether AC is compatible. AC, for AC we have the implied pair BC only. Now check for BC, BC is also compatible. So we can write that AC is compatible and its implied pair is AC is compatible and its implied pair is BC. Now check for AD. Now AD, whether AD is compatible. AD has implied pair EF and BD. Now check for EF and BD. EF and BD. Now for BD, obviously it is not compatible, because for FF we have the different outputs. So we can write the, you can straight away you can say that AD is not compatible. Now let us check for whether AE is compatible or not. Now for AE we have the output for input I1, we have the output 0 and 1, so it is not compatible. For AF we have the implied pair ED and BB. BB we will not check. Now let us check the compatibility for the implied pair ED. Now for ED it is obviously compatible, so we can write that AF is compatible and its implied pair is DE. Now check the compatibility for BC. Now for BC, BC will be compatible if AC and EF is compatible. AC is already compatible. Now let us check for EF. Now EF is also compatible, so we can say that BC is compatible and its implied pairs are AC and EF. Now check the compatibility for BD. Now BD is not compatible. Now BE. Now BE is also not compatible. Now for BF, BF will be compatible if FD and AB is compatible. AB is already compatible. Now let us check for FD or DF. DF is also compatible, so we can say that BF is compatible and its implied pair are AB and DF. Now let us check for CD. CD will be compatible if EF and CD is compatible. Now CD we don't have to check, now we have to check for EF only, whether EF is compatible. Yes, EF is compatible, so I can say that CD is compatible with its implied pair EF. Now let us check for CE. CE having the implied pair EC and CC. So for C is implied pair, so in the same state for which we are checking the compatibility, that cannot be considered as the implied pair. So I can say that C is compatible, but it does not have any implied pair. Now let us check for CF. Now CF will be compatible if BC and DE is compatible. Now B and C is compatible, and then DE. Now let us check for DE. Yes, D is also compatible, so I can say that CF is compatible with its implied pair BC and DE. Now let us check for DE. DE, whether DE is compatible. Now DE will be compatible if its implied pair CF and CD is compatible. CD we have already checked, and then CF is also we have checked, then both are compatible. So I can say that DE is compatible with its implied pairs CF and CD. Now let us check for DF. Whether DF will be compatible if DF and BD is compatible. Now check for BD. Oh, BD is not compatible. So what I have to write that DF, the implied pair is BD, but BD is not compatible. Okay. Now let us check for ED. Now EF will be compatible if CD and BC is compatible. Now let us check for C and D. CD is compatible, and then BC is also compatible. So we can say that EF is compatible with its implied pair BC and CD. So this is my total merger table. Now check the cross compatibility checking. As BD is not compatible, so DF will not be compatible. Now we have to check that whether DF is compatible or not. Now in DF, so whether DF is an implied state in any compatible pair or not. Now DF, yes, DF is implied pair over here. As DF is not compatible, so BF will not be compatible. Now we have to check that whether BF is acting as an implied pair of any compatible pair or not. No, BF is not acting as any implied pair. So this is the refined merger table. Now from that merger table, either you can draw the merger graph itself also, or you can go directly for compatibility graph. Now let us draw the compatibility graph separately. Now, to draw the compatibility graph, we have to draw the merger graph again, merger table again. So, this is the merger table. From that merger table, let us draw the compatibility graph. Now, from AB to EF, there will be one directed edge. AC to BC, there will be another directed edge. AD is not compatible, AE is not compatible. AF to DE, AF to DE, there will be another directed edge. Sorry, I forgot to write about BC. BC is AC to CF. Now, for BC, BC is AC and then EF. Now, look at here, from BC to AC there is another graph is already present, right? Now, I can add it over here. So, what I can do that, AC to BC is there, so I can draw like this, and I can remove this one. And for AB to EF is present over here, you can see that AC to, and I can add it over here. So, if I draw this one, what is that? AC to EF, oh sorry, AB to EF. So, if I draw AB to EF, then it will be quite like this, AB to EF, and I can delete this one, and AF to DE I cannot connect. Okay, fine. Now, go for CD to EF, CD to EF over here. So, I can write CD to EF, then CF to BC, CF to BC. So, if I write CF over here, I can draw it CF to BC, then CF to DE, CF to DE, DE, okay, CF to DE is there. So, let us draw this one, AF to DE. And CF to DE, CF to DE. Okay, fine. Then DE to CD, DE to CD. Okay, DE to CD, this one. Then DE to CF, DE to CF. Okay, DE to CF. Fine. DE to CF and DE to CD, DE to CD. Okay, fine. Then EF to BC, EF to BC and EF to CD, and then EF to CD. Look at here, last example we are in a dearth condition to get the closed loop. Here we are getting 1, 2, 3, 4 closed loops, so it is very difficult to find out which one to choose now, and it should be minimal closed covering. So in this cases, let us choose it randomly. So if I choose AB, look at here, as a part of my closed set of compatibles, then I have to include EF also. I have to include EF, and EF has CD and BC. EF has CD and BC. So this part I can choose it independently, where AB has implied state EF and EF has implied state CD is present over here, and EF has implied state BC is also present over here, and BC has implied state AC. So I have to include AC here also. I have to include AC here also. So I must get that AB, EF, CD, BC and AC, which will be which can create one closed set of compatibles. Now this one is this covering all the states. A is present over here, B is present over here, C, D and EF all are present over here, but unfortunately I have to include BC and AC. But this one, if we consider the transitive law, look at this, AB, BC and AC all are present over here. So as per transitive law and transitive property, can I say that ABC is compatible together? Instead of considering AB, BC and AC separately, I can write ABC and rest of the states are CD and EF. Then this will be my minimal closed covering, because this one is closed set of compatibles, as all the states and its implied pairs are present over here. This one is covering all the states A, B, C, D and EF, and this one is minimal because total number of states are 6 and only minimal possible pairs can be 3 only. So 3 pairs are present over here. So this one is the minimized answer. Now what should be my resultant value, resultant table? So I have ABC, I have CD and I have EF. Now consider ABC as alpha, CD as beta and E as gamma and create the table. Now for ABC, if I consider A, if you have the table, you can find it out. If I consider A as alpha, because A, B, C all will maintain the same property because they are equivalent. So it is E0 and B0. So I can write it as gamma 0, and for B0 I can write it as alpha 0. And for CD, if I consider C as beta, I can take any one of them, either C or D. So if I consider C as beta, then it is E dash. E dash means gamma dash, and then C0. C is beta 0. The next one is EF. If I consider E only, then it is C1 and C0. C is beta 1 and beta 0. This one is my resultant answer.